So students, now let's try to understand about what exactly is a capacitance. Capacitance is basically the capacity of any conductor to store charges. When you have a basic type of a conductor in the form of two parallel plates. You have two parallel plates, you connect them with respect to an electrostatic potential, then there is going to be a flow of charges taking place. This is the basic form of a capacitor. You can increase the capacitance, as you will see later on, with the help of a dielectric. A dielectric makes and produces an electric field, and that external electric field in the presence of the dielectric field results into a net value of the electric field. This is the thing that we are going to discuss further when we try to understand about the parallel plate capacitor. So stay tuned for that. Now let's move on to understanding about the capacitance. What does capacitance mean? Capacitance is basically the capacity of a particular capacitor to store charges. So what basically is a capacitor? Capacitor is something that stores charges, right? So the basic way of constructing a capacitor is that you just have two plates. Within two plates, and if you apply an electric external potential difference, so obviously there are going to be charges which are going to be static, because you cannot have, without there being any physical medium, the charges cannot be transferred. There cannot be any current flow taking place, but you can still have charges induced on the other plate by induction. So let's try to understand about that in this particular thing, that is, what is the capacitance of a conductor. So if you have any particular conductor, in that case, when a conductor is given any particular charge Q, so for instance you have this particular conductor, this has been given any amount of charge. So equal amount of charge is going to be distributed across it. So if I say a negative charge is going to be here, a positive charge is going to be here, and a potential difference has been applied across its end. So let's say V is the potential difference that has been applied. So there is a capacity of this particular conductor. So how much is the capacity? The capacity of this particular conductor is going to be given by how much is the charge that you have stored, and amount of charge storage is going to be dependent upon how much is the potential difference that has been applied. So V is the potential difference, C is the capacitance, Q is the charge. So this is how we define the capacitance of the conductor. What exactly is the principle? And this is basically an arrangement for storing a very large amount of charge. The capacitance of a charge conductor, you can increase it by making one of that as an uncharged. Basically you ground that. So when you connect one of it to the ground, so it basically gets earthed. So that can be, so whatever charge you have is going to be stored on one of it, and you will find out the capacitance with respect to the ground. So that this way you can increase the capacitance of the conductor. Now let's try to understand more about it in the basic one of the capacitance, that is a parallel plate capacitor. So we learned about what exactly is a capacitor. The basic way of explaining or expressing the expression of a capacitor in the form of the area of the plates, because higher is the area of the plates that you have, higher is going to be the amount of charge that you can store in it, and therefore the charge density. For a uniform charge density, if you increase the area, effectively the charge can also be increased. And it is also going to depend upon how much is the charge, how much is the distance the charge needs to cover. That is the distance between the plates. So effectively the capacitance is proportional to the area of the conductor of the two plates and the distance between the two plates, assuming both the plates have the same amount of area, else it has to be figured out differently. So this was the basic form of a capacitance. Now, as promised, we'll now move on to the case of parallel plate capacitor.